Aw, man, not another volume problem. What is the volume of the solid generated when the region in the first quadrant bounded by the graph of this guy and the x and y axis is revolved about the y axis? Okay, first challenge right here is that we're revolving about the y axis. That means we have to have a function that is defined with y's, not with x's. Right now we have this function y defined with x's, and so we're going to have to change that so that it has the y's on one side. This is pretty much the graph that we're looking at, just so you guys have a visual. This is like half an ellipse, I believe. But to get us started, to solve for the x instead of the y, I'm going to square both sides, and that gets rid of the square root, and then I'm going to put the 4x squared on the same side as the y squared. Now let's get the x alone. So to do that, I'm first going to divide everything by 4. I know I'm weird. I'm kind of going out of order here. And then I'm going to move that y squared to the other side, and it's a 1/4 y squared. Okay, and then I square root. Now when I square root, I get a plus and a minus. Now what that gives us is actually both sides of this line. Okay, it actually gives you all of this side, and it gives you all of this side. But we only care about the one in the first quadrant. Okay, so I'm just, excuse me, I'm going to delete the extra, what are those called, signs. And we're just going to use this guy, because this would define the curve in the first quadrant. Because that's what it says right here in this problem. It says we are in the first quadrant. Okay, so how do we revolve this dude? How do we find the answer here? Well, if you have a volume of revolution problem, it would first of all kind of give you, like, just to give you a visual, it would circle like this. You would have these cross sections, and I chose to draw this one. There's actually a lot of them right here that are all circles. And so we're going to use the area formula pi r squared. Okay, and then we're going to sum all of those areas together. So here I have the pi and the r squared. I did take out the pi because he is unaffected by taking the antiderivative with respect to y. I do have a 0 because I know that the x-axis is a boundary. And then the highest y value that we're going to pick, and that's right, I said y value, not x values. The highest y value we're going to pick is going to be whatever this x or this y-intercept is. So I'm going to go back to one of my equations. I'm going to choose this guy down here, and I'm going to set that one equal to 0. I'm just now realizing I could have just put the 0 into this x right here because this is technically the same equation, but I already did it with the other equation. So first I square both sides. Now the square root's gone. I subtract 25. Then I multiply both sides by -4. Then I have a 100 equals y squared. So y is going to be positive and -10. We don't care about the -10, that's down here. We only care about the positive 10 because that is the number that is affecting our first quadrant. So our upper bound is 10. Now we have to define the radius. Now the radius has to be defined with y, which is why we got this this equation written in terms of y. So what happens here is we have to choose a y, and that y has to give us the result, which is an x. The x would give us the distance from the y-axis to the outer curve right here, whichever circle you're on, okay? Which is why we did this, all this business down here. Okay, so I'm going to plug that into my radius because that actually is my radius. No other hard work to be done there. Once I plug in the radius, I square it. Yay, the square root goes away. Everybody rejoices. And then we can just plug this into a calculator and we win. We're done. I did use a Desmos calculator, and this is how it would look in Desmos. I know this is a calculator problem because it has a calculator symbol right here. Just make sure you guys put parentheses around the integrand when you guys are using Desmos. And don't forget your dy right there. You got to have that.